First of all, I would like to thank CSC coordination team for providing this opportunity for us to present our research. So today I'm going to talk about temporal and spatial assessment of landfill gas emission near the city of Regina Landfill, and my name is Karimi. So as an overview, we will talk about remote sensing application in solid waste management and the ability of monitoring methane gas hotspots by satellite imagery, and then the using frequency of occurrence for landfills, temperature in Regina landfill, and finally I will show how I use the applications to detect the source of landfill gas. And I also included an image here for you to show how landfill gas can be captured out of our landfills once we detect the methane gas hotspots in our landfills. In current slide, I'm going to talk about remote sensing application in solid waste management and its importance. The first one is siting waste facilities. Why this is important? Because if you want to site a waste facility, there are different criteria and restrictions that you have to address. The first one is water resources. You want to be out of water resources because you want to protect them. You want to be out of protected areas. You want to be out of mountainous areas because of the slope. You want to have access to the road network because of the communication and connection. You want to be out of urban areas because sometimes people do not want to locate their waste facilities in their neighborhood. Then what is the better and suitable way to concatenate and aggregate all of these restrictions together? It would be again satellite imagery, because they can provide different maps and different applications for you to address all of these issues. The second one is evaluating adverse effects of waste facilities. Sometimes the location of the landfill is very important because we have very biodegradable materials that is integrated in one place and we want to eliminate them. And if you want to prevent some of those adverse consequences, first of all, you have to understand and detect that specific issue. For example, higher surface temperature within landfills. We already have some tools in satellites that they can capture the higher surface temperature from the land. Then we can use these kind of tools to detect that specific spots. Or for example, sometimes your vegetation cover quality already decreased, and we can capture these decreased low quality vegetation cover by using some indices like NDVI or SAVI, and these are just explained within the remote sensing applications. And in current study, we are going to use the frequency of occurrence of the land surface temperature as an indicator to extract the methane gas hotspots within our landfills. In this slide, I show you how we can use remote sensing imagery to capture the methane gas hotspots within our landfills. So landfill gas, mainly methane, is a byproduct of waste decomposition in landfills. And the decomposition process increases the land surface temperature, and at the same time it releases the methane gas. So capturing the land surface temperature means detecting methane hotspots. However, I also wanted to show you that methane could be captured and converted to a source of energy, but on the other hand, it could be also released to the environment and became a source of air pollution and occur explosion danger in landfills. So it's our call to use it as a part of energy or release it as a pollution to our environment. And we also included an image here to show that a pile of waste can increase the surface temperature by having those biodegradable activities. However, at the same time, it could also release methane. but unfortunately satellites sometimes cannot detect the methane release. However, they can detect the higher surface temperature. That's why we are using these satellites to capture the surface temperature as an indirect way of detecting the methane gas hotspots in our landfills. So in our current study, you can see that we selected the city of Regina landfill, located at the northeastern part of the Regina, Saskatchewan, with a size of around 1.2 million square meters, and the Landsat imagery from February 5th to November 27th just selected for this area. And for the year of 2018, we selected 14 satellite imagery within this period of time. So I want to have a quick look for this current study workflow to show you how we construct our study and research. So first of all, we selected the area, which is regional landfill, and then we started to acquire satellite imagery, and we downloaded them, and then we aggregate all of them. So we started to calculate the land surface temperature within the landfills by our formula, and then we extracted the relative increased land surface temperature by understanding the average land surface temperature and also standard deviation. So we already have the land surface temperature, and by adding a standard deviation on top of it, we can have the higher level of the surface temperature within our landfills. And then we started to detect the probable potential gas release points and polygons, and we started to analyze these, for example, 14 images and their displacements over time, and report the gas hotspots. And finally, we just reports in the final potential methane release gas hotspots. So the novelty of our work is the aggregation of frequency of occurrence and land surface temperature in extracting methane hotspots from landfills. In this slide, you can see that we extracted the methane gas hotspots within each individual season, starting from winter to spring, summer, and then fall, and finally we aggregate all of them together to come up with the frequency of occurrence map at the bottom right hand side. And you can see that our legend starts from 0 to 14, which means that sometimes we already have some spots that they do not have any higher surface temperature and their value is equal to 0. However, sometimes we do have some hotspots that their values is equal to 14. It means that in all of those 14 scenes that we downloaded within the year of 2018, that specific hotspots captured as relatively higher surface temperatures, and that's why their value finally became 14. And sometimes we already have some spots that their values just fluctuates from 0 to 40. However, at the end of the day, you can see that our methane gas release regions specifically is focused at the southern central part of the landfill. However, in some seasonal images like winter, spring, you can see that we already have very small spot of higher surface temperature at the northern central part of the landfill as well. So we can safely conclude that high association between higher land surface temperature and methane hotspots in landfills enable us to detect and monitor landfill gas. Seasonal land surface temperature show similar location of methane sources with very slight displacements, and it means that no matter which one of those seasons you want to focus, at the end of the day you come up with the same results. And frequency of occurrence map discovered two major sources. of methane at northern and southern central part of the landfill. And finally, higher frequency of occurrence could be because of high organic proportion and higher volume of piled waste in our landfill. Others would like to thank University of Regina, Faculty of Engineering and Applied Science, Faculty of Graduate Studies and Research, NZERT, Faculty of Engineering Research Opportunities Fund for their support, and we will be more than happy to answer the questions during the live Q&A session. Thank you.